Hi everyone. Today we're going to study pair of linear equations in two variables. Let's begin with linear equations in two variables. An equation which can be put in the form ax plus by plus c equals 0, where a, b, and c are real numbers and a and b are not both 0, is called a linear equation in two variables x and y. Examples: 2x plus 3y equals 5, x minus 2y minus 3 equals 0, x minus 0y equals 2. In our third example here, we can simplify this as x equals 2. A solution of such an equation is a pair of values, one for x and the other for y, which makes the two sides of the equation equal. Example: show that the ordered pair 1, 2 is a solution to 2x plus 3y equals 8. For the solution, we substitute x equals 1 coming from this and y equals 2 coming from this to the equation and check the equality if satisfied. Our equation is 2x plus 3y equals 8. So it becomes 2 times 1 plus 3 times 2 equals 8. 2 times 1 is 2 plus 3 times 2 is 6. The sum 2 plus 6 is 8, which is equal to the value on the right, which is 8. Since the equation is satisfied, then the ordered pair 1, 2 is a solution to the given equation. Geometrically, a linear equation in two variables ax plus by plus c equals 0 represents a line on the plane. Now, each solution xy of a linear equation in two variables corresponds to a point on the line representing the equation, and vice versa. Let's go now to the pair of linear equations in two variables. The general form for a pair of linear equations in two variables x and y, we have a sub 1 x plus b sub 1 y plus c sub 1 equals 0. A sub 2 x plus b sub 2 y plus c sub 2 equals 0, where a sub 1, b sub 1, c sub 1, a sub 2, b sub 2, c sub 2 are all real numbers. A sub 1 square plus b sub 1 square not equal to 0. Also, a sub 2 square plus b sub 2 square not equal to 0. We have examples. This is the first example. The first pair is 2x plus 3y minus 7 equals 0, and 9x minus 2y plus 8 equals 0. Second pair, 5x equals y, negative 7x plus 2y plus 3 equals 0. Another example, x plus y equals 7, 17 equals y. Geometrically, the pair of linear equations in two variables represents two straight lines on the plane. Given two lines in a plane, only one of the following three possibilities can happen. Number one, the two lines will intersect at one point. As shown on this figure, this is the point of intersection. Second possibility, the two lines will not intersect. In this case, the lines are parallel. Here's an example of two parallel lines. Third possibility, the two lines will be coincident. This is an example of two lines that are coincident. We said that wherever the first line go, the second line go on that same path. Example 1. Akila goes to a fair with 20 rupees and wants to have rides on a giant wheel and play hoopla. The number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride cost 3 rupees and a game of hoopla cost 4 rupees, how would you find out the number of rides she had and how many times she played hoopla? Represent this situation algebraically and graphically, or we say geometrically. First, we assign variables for the given. Let x be the number of giant wheel rides and let y be the number of hoopla played. The first condition on the problem is the number of times she played hoopla is half the number of rides she had on the giant wheel. We represent this in the equation as y equals 1 half times x. This is our first equation. For the second condition, it says each ride cost 3 rupees and a game of hoopla cost 4 rupees for a total money of 20 rupees. We represent this as equation as 3x plus 4y equals 20. This is our second equation. Now we're going to draw the two lines. As per the process, we're going to identify any 2 points of the line. Let's begin with the first one. This is our table. The first row is for the x, the second row for the y. For the y here, we will copy the equation down here. Then, we assign value for x. Let x be 0. We substitute the 0 to the x and we will get the value of y as 0. We assign x to be number 2. We substitute this 2 to the x in this equation. We will get the value of y as 1. So, for the first equation, the 2 points are 0, 0 and 2, 1. Let's go to the second equation. This is our table for the second equation. The first row is for the x, second row for the y. For the first row, we put here x. For the box here, we rearrange our equation 2 in such a way that the y variable is alone on the left side. So we have this y equals 20 minus 3x over 4. Then we assign x value to be 0. We substitute 0 to this equation, then we will get the value of y as 5. Next, we can assign 0 to y. Then we can solve for x and the value will be 20 over 3. Therefore, for the second line, the 2 points are 0, 5 and 20 over 3, 0. From here, we're going to connect the 2 points respectively to form the two lines. These are now the two lines. This is our line 1. This is the y equals x over 2. But when we simplify that, it is equal to x minus 2y equals 0. This is the second line. This is the line 3x plus 4y equals 20. Observe that the two lines intersect at the point 4, 2. In this case, we say that x equals 4 because this is the x coordinate. Therefore, Aquila got 4 rides in giant wheel. And for the y equals 2. It means this 2 is the number of hoopla plays. And this is now the final answer. Example 2. Romila went to a stationery shop and purchased 2 pencils and 3 erasers for 9 rupees. Her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of the same kind for 18 rupees. Represent this situation algebraically and graphically. We let x be the cost of 1 pencil. We let y be the cost of 1 eraser. So the first condition is the Romila's purchase. Romila purchased 2 pencils and 3 erasers for 9 rupees. So we write here 2x plus 3y equals 9. This is now our equation 1. Second condition is Sonali's purchase. Sonali bought 4 pencils and 6 erasers for 18 rupees. So we write 4x plus 6y equals 18. This is our equation 2. Now let us draw the lines. Let's identify any 2 points of each of the equations. Let's begin with equation 1. This is our table. We have the row for x, we have the row for y. For the row for y, we rearrange our equation in such a way that y is alone on the left. So this is equal to 9 minus 2x over 3. Now we assign value for x. Let's say x equals 0. We substitute 0 to this equation. We can solve for y, and that is equal to 3. Also, we can assign 0 to y, then we can solve for x, and the value will be 4.5. Therefore, the 2 points for the first line are 0, 3 and 4.5, 0. Let's go to the second equation. This is our table. Row for x, row for y. For the y formula, we rearrange our equation 2 in such a way that y is alone on the left. So we have 18 minus 4x over 6. Now we assign value 0 for the x. We substitute it here and we can solve for y, and the value is 3. Also, we can assign 3 for x. We substitute that value here. The value of y will be 1. Therefore, the 2 points for the second line are 0, 3 and 3, 1. Now, let us connect the points respectively to see the 2 lines. And here are the lines. This is the line for 2x plus 3y equals 9. This is the same line for 4x plus 6y equals 18. We can see that the 2 lines are coincident because the 2 equations are equivalent. Example 3. 2 rails are represented by the equations x plus 2y minus 4 equals 0 and 2x plus 4y minus 12 equals 0. Represent these equations geometrically. Let us draw the lines. Again, let us identify any 2 points of the lines. For the first equation, we have this table. We have the row for x, we have the row for y. For this equation here, we rearrange the first equation in such a way that y is alone on the left side. So we have y equals 4 minus x over 2. Then we assign 0 for x. We substitute 0 to this equation, and the value of y is 2. Also, we can assign 0 to y and we can solve for x. We substitute 0 to the y here and the x equals 4. So we have 2 points for this line. The points are 0, 2 and 4, 0. Next, our second equation. This is our table of values. Row for x, row for y. On this box, we rearrange our equation such that y is alone on the left. So we have y equals 12 minus 2x over 4. Now, let's assign 0 to x. We substitute 0 to this equation. The value of y is now 3. Next, we can assign 0 to y here. Then we solve for x. The value of x will be 6. Therefore, for the second line, the 2 points are 0, 3 and 6, 0. Now we are ready to plot the points and connect the corresponding points. Here are now the two lines. This is the first line, the x plus 2y minus 4 equals 0. This is the second line, 2x plus 4y minus 12 equals 0. We can see that the two lines are parallel.